Hi, I'm Max Schneider, and I'm a research statistician at the U.S. Geological Survey. I wish I could have been in person, but I'm still excited to present this work from our international and interdisciplinary team on aftershock forecast and how to visualize them based on user needs. So it's known that after earthquakes, we can expect more earthquakes or aftershocks. Some of them can be even more damaging than the triggering earthquake, the main shock. This was the case in 2011 in New Zealand. Even though we can't predict earthquakes, the aftershocks afterwards will follow well-known seismological laws that describe their severity, their times, and their locations. And these can be built into a forecast model and that we can use to better understand seismic risk and thus reduce it. Since 2018, the U.S. Geological Survey has been issuing aftershock forecasts to the public for earthquakes of magnitude 5 or greater in the U.S., and also delivering forecasts for earthquakes outside the U.S. to our government partners. Aftershock forecasts are spatiotemporal. They describe the number of aftershocks and how those aftershock rates change per time window or spatial area. So, and we can see this in the top plot here that shows the number of aftershocks per day following the damaging New Zealand earthquake and how quickly this decreases with time. That's showing aftershock rates, but we can also forecast the ground shaking that we expect from those aftershocks. And so this map on the bottom shows how the probability of shaking that's above some slight damage threshold varies over the region around the New Zealand earthquake. So these are examples of forecast products that communicate the forecast, and we have reason to believe that visual products can better communicate aftershock risk than just tables or text. And so the challenge is to design these visual products around what users actually need. And so who are these users and what are they using aftershock forecasts for? This is a really small list, but we know from focus groups in New Zealand that civil engineers used aftershock forecasts before going in to inspect damaged buildings. Emergency managers use them to allocate resources across the affected area, and science communicators delivered information to wide audiences based on the aftershock forecast. So each of these different use cases gives rise to distinct user needs, ways in which the forecast should be packaged and provided. And what we know from focus groups is that these user needs for aftershock forecasts do vary across profession. But it's not clear how visual products that can be made to communicate the forecasts can support such a diversity of use cases across very different professions. Furthermore, forecasts often need to be communicated across national borders, and it's not clear from the literature how user needs vary by country. So we have a research program for designing and testing visual products for aftershock forecasts. The first step is to gather users from target groups into workshops where they do activities that elicit their user needs. Then we can design aftershock forecast products that are aligned with distinct user needs we learned about in the workshop. Then we can test a subset of those new products using a task-based experiment. So here, participants do tasks that will align with the use cases that we learned about in the workshop. And then analyzing that experiment will reveal how those forecast products that we designed to meet user needs, how much they actually did. We're doing this work across 3 countries, the US, Mexico, and El Salvador, that all have high seismic activity, but different socioeconomic situations. And because of their close proximity, we could expect to be issuing forecasts across national borders there. So for the workshop, we recruited from a number of target groups. These are professions that are current or prospective users of aftershock forecasts that we categorize in 3 ways. So there's those users who take forecasts in a holistic and qualitative way to make wide-ranging decisions. So think of emergency managers and firefighters who have to decide how to perform urban search and rescue under the threat of aftershocks. Then there are those users who take the aftershock forecast as numbers and do calculations and other technical operations in their work. So this is a range of engineers or critical infrastructure operators who need to assess their damaged, or the infrastructure for damage following an earthquake. And then there's those users who are communicating the forecasts and corresponding risk to wider audiences, and that's geoscientists, public information officers, and the media. So we recruited for our workshops from these groups. Now, prior to the workshop, we needed to introduce the topic to people, and we did that with a non-technical report and a webinar. And we asked participants to identify use cases. So we mean that specifically as decisions related to their work in earthquake response that could be informed by an aftershock forecast. And the workshop, we had two main activities. So first, we split the participants by profession. We provided each of them a hypothetical, like the same hypothetical main shock, a magnitude 7.2 happens in your area. And then each group had to choose a use case that represented their profession. Then they had to come to consensus on which aftershock forecast info would actually support that use case. Is it the number of expected aftershocks or the probability that one will be large? Is it aftershock rates or aftershock shaking? And how should that information be visualized, packaged, provided in a product? And we asked them to think about three distinct time windows: the first day, the first week, and the first month following the main shock. Then we repeated that activity, but with new groups that are mixed across profession. And we gave each of them a common use case. So we asked them to consider how they would distribute resources following a main shock, where resources could be their equipment or their teams or their shelters, something that was relevant to their profession. And again, they had to come to consensus across professions on their information and product needs. All right, so what did we find? Well, across all those professions and countries, the most commonly requested product was a map showing the forecasted shaking. So like this map here that shows the chance of strong shaking next week. Now, some groups wanted this map to be animated so that you could see how the forecasted shaking decreases with time. The more quantitative use cases wanted to see a very detailed map with lots of information. They wanted the raw data to be downloadable. Those that had more communication use cases wanted the map animated, but really simplified with just a few, maybe 2 or 3 colors, but specific ones. They specifically requested reds, for example. There's lots of other profession-specific needs that folks reported, and I invite everyone to see our short paper for those. Now, when we mixed the groups across professions, we found that consistently, the different groups requested interactive forecast dashboards that had lots of products, that had maps like this shaking map that you could add different layers to of the previous aftershocks that happened, or of your points of interest where your infrastructure lies to contextualize the forecast. We also found that user needs changed with time since the main shock. So right away, they wanted the spatial information and they wanted it for short forecast durations. But later on, when the task shifted from earthquake response to recovery, they wanted longer forecast durations, and they also wanted more information about rates. They wanted to see how those rates would change with time, and they wanted to see tables like this of earthquake rates binned by the time and magnitude. We did find that there was some variation by country, but it was actually smaller than by profession and time since the main shock. And so I'll conclude there, and thank you so much for your attention, and happy to get questions by email or Twitter too. Thanks.